and for the benefit of those that did not come from last session. So convolution layers were inspired by the human brain. We noticed that how our eyes perceive neurons and the image pathway results in this thing that's very similar to neural networks, but it's actually this thing that inspires neural networks. So you can refer to this video by Vsauce. It's a very good video on how the human brain perceives images. So this is the first paper actually in 1980 that tries to create a mathematical version of this biological pathway. So they were the first to actually create these convolutional layers. So back to a recap of how convolution layers work. This is an animation of one with an image of size 7 by 7 with 3 channels, creating an output shape of two tensors of 3 by 3. So normally our images will come in 3 channels, such as this. There will be 3 squares or 3 rectangles. So each rectangle represents the R, G, and B values, the red, green, and the blue values. So that's why you get a colored picture. So the convolution filter, as you can see, is this green color square that's going through it. For this example, is spread out more because of this option. You can actually search up more on the parameters actually. Yep, so that convolution filter looks like this is because of the dilation value. So we can go back here. Yep, and this is just a better visualization of how convolution works for those that missed out on last week's workshop. So you can argue, for those that are wondering why convolution layers, so if you realize linear layers can actually be kind of like represented by, instead of convolution layers. So why we do convolution? Because number one of the most important one is actually parameter efficiency. So you notice for such a big image, we transform it to small ones. We only need a few amount of weights as compared to linear layers. So there's also spatial hierarchies, which is also very important. So actually, let me use the GUI as an example. So let's say we are trying to draw an image. If we use linear layers, a one that looks like this will be interpreted differently from a one that looks like this, because its position is different. But for a convolution layer, it will look the same. Yep, and that's what this tool is trying to say. So now I'll be covering autograd, which is how PyTorch calculates its gradient. So by this time, I expect you to have finished most of these parts on the Jupyter notebook they can try out. And you should be around here at autograd. So for autograd, this is just how you can zoom in. Yeah. So for autograd is how PyTorch calculates gradients. So it just behaves like a stack for those that have taken data structure and algorithms. The gradient functions are added into the stack and is first in, last out, basically. This is a better graph of how gradient accumulation works. If you have two tensors A and B, and you multiply them together, you create a tensor C. And this tensor C contains information about what operations has been done on it. So in this case, it's multiplication. So PyTorch will have a gradient function called multiplication backwards. So this will be used to calculate the gradient when you run C dot backwards. And the gradient will be accumulated, then updated in A and B, in the gradient part of A and B. And this gradient value will be used when you do optimizer.step. Yep. So you can run the Jupyter notebook and you can see that these are the gradient objects. They are created when you perform several operations. So for example, if you do ReLU, the linear activation function, you'll get a ReLU backwards object. And if you do a max pull operation, you'll get a max pull backwards. Yeah, so this is how PyTorch does its backpropagation and how it calculates gradients. So now we will be going through floating point operations. So this is the next part in the Jupyter notebook. For those that have taken digital logic or digital, the triple E version is what? Digital. Yeah, digital electronics. You'll probably encountered this word before, floating points. So actually, as the Jupyter notebook shows, numbers are stored in this format by the IEEE convention, if I'm not wrong. Where there's a sign bit, then there's the exponent and the mantissa. So this is similar to the scientific notation. So normally it's stored in float 32 to maintain a high level of precision. So if you run Python or you're familiar with programming languages, you know that decimals are not accurate. So let me show you an example. I cannot see. Wait. Hold up. The on top thing is gone. Okay, but never actually I'll remove this actually. Yeah, so if you do something like this, you'll notice that Python gives you this, which is a very weird number. So this is partially also due to this. Wait, let me zoom in. Yeah, when you do 0.1 plus 0.2, it'll give you this weird number. So this is because computers store numbers in this kind of format. So it's impossible to, for example, to get 0.3 accurately. So you notice that more precise numbers, such as this 0.1623 blah 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 times 0.18 blah 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 is much harder to calculate than just 0.16 times 0.18. So what people have realized is that you can just make the numbers less precise. So what this results in will be faster models and lesser storage required to store the models. And NVIDIA has done, this is a graph from NVIDIA that shows how memory usage lowers and performance increases when you reduce the precision. But of course, there's a downside to doing this. When you lower the precision of your weights or your data, there is a chance that your model will become less accurate. So now we'll be moving on to TensorFlow. Actually, we'll go through this very quickly. Oh yeah, and if you're following the Google Colab, it has a tutorial of how to change the precision in, how it goes through the precision in PyTorch. So it has this thing called Python has a context manager. So you do with the torch.autocast device CUDA and d type equals float 16. So in this case, you change to FP16. So what the context manager does is that you run this code with this option on. So this training loop called trainnet mixed precision is here and the original one is here. Just for this case, if you notice, the time taken for the mixed precision is actually only a very bit shorter than the normal one. And if I'm not wrong, on some machines, your time here might actually be longer than the previously. This is because for small models such as this, the time it takes to change the precision actually outweighs the benefit you get when you compute the numbers. Yeah. Okay, actually, for those that want to do the GUI, there's one part that you need to take note of. When you download, there's one cell where you save the model. This cell. So if you want to do the GUI later, you can download the save weights from here. So just download this mnis.pt if you want to try the GUI later. So now I'll be moving on to TensorFlow. Actually, this will be a very fast part because most of our future workshops will be in PyTorch. And the reason why I'm going through is that for some of you that want to work in ML companies or want to do some machine learning job, machine learning engineer jobs, some companies will force you to use TensorFlow and Keras. Also, some projects will be easier if you're done in TF, because in PyTorch, you have to manually call out every single layer. In the example, I'll show you the difference. And it's not really necessary, and it's your personal preference, actually. So in the notebook, you can notice how much different the TensorFlow code is. So it's actually labeled so you can read, but notice the difference. You can just straight away use model.compile and model.fit, which is much simpler than PyTorch, where you have to actually write out a training loop. So you can try it out. There's a timing here where it shows the difference in GPU and CPU also, I believe. Yeah, which also again shows how much faster GPU is compared to CPUs. So now I'll move on to GUIs, actually, for those that have, this will be quite important for those that want to do projects or hackathons. So the two main Python GUIs are Streamlit and Gradio. This allows easy integration between Python programs API with a front end. So later on, you'll see, because your front end is Python code and your model is also Python code, this allows very easy integration. So it's also extremely simple to use and install and to deploy. So you don't need to learn very quite hard front end concepts such as the event loop and stuff like that. So it's very, very good for projects and especially hackathons because of how fast it takes to just create an app. So for this workshop, I'll be focusing on Streamlit instead of Gradio. So Streamlit bridges Python and React. Underneath the hood, Streamlit actually converts your Python code into React code. So it will create a JavaScript app, a reactive JavaScript app. So if you want to try to follow the Streamlit tutorial later, first you should create a new directory with either your File Explorer with your Windows, or you can try using make directory on your command line and cd. Actually, I will go through this step by step. I'll zoom in onto the good point. I'll make this very, very big so you can see. So I'll first make the MLDA in this case. So in other words, I'm making a directory called MLDA. And this is the, yep. So if I run this code, you'll create a folder called MLDA that I can CD into. So I'll run cd next MLDA. So which is change directory MLDA. So in other words, I'll enter this folder.
Can you try install the pip as well?
Okay.
Just code that you share and then stuff.
So for those that haven't yet, I'll slowly go through also. Oh, it does. Yep, because I've already installed it, it's actually quite fast, and it says all the requirements are already satisfied. So for those that haven't downloaded yet, it will probably be slower. Then you have to install the rest also. And because I already installed it, it's very fast, but if you haven't yet, it's quite slow. So if you install it properly, if you run Streamlit hello, it will look like this. This is the default, the kind of default web page that you will get. If you use React, you will probably see something similar to this also, if you have done front end before.
So, so this also ties into the very, very first workshop. If you recall, the first workshop is about programming environment. So over there, I did share about how you can install the Python, or wait, can you mute Brian? I think it can echo. Yeah. So at the start of the whole workshop series, I did share about the programming environment how you can use Conda or just straight up using Python. And the command that Brian just run just now, pip install, it is up to you to run on your local machine environment or in a Conda environment. So the idea here we want to stress is that it was quite a change of pace, right? We are shifting from the Google Colab environment. Now we are like going to develop. You have to develop your thing locally on your computers using these various like GUI libraries because it also gives you more control. Yeah. So previously we used Google Colab in order to demonstrate the deep learning concepts. Now, if you want to translate those deep learning concepts and models into an application, then this is where you should start developing in your own local computers. Yep, and that is the only thing that I want to add on. You can follow the machine learn MLDA handbook. Scroll all the way up at the very first workshop where we talk about the environment for more detail. Yes. Okay, Brian, please continue.
Okay, I have to restart what I said just now. For those that have done downloading or already downloaded, if you run Streamlit hello, it should be okay and show something like this. Welcome to Streamlit. If you have any problems downloading, you can point it out in the chat. But yeah, then we'll be now from last week's workshop, we have done the MNIST digit identification. So this week we'll be trying to deploy it. So in other words, make a GUI out of it that other people can use in order to try your model. So in this case, front end is actually very, very simple because you already know what you want and all you're doing is describing it. So for this case, it's very simple. There's two tags at the top. The user input canvas where you draw the number. The process input where you change the numbers resolution down in order for the model to take it in. And the model output, in this case, it is a 7. And this is what the one hot, the final array of 10 elements that I talked about earlier will look like. So the code for it will look like this. Actually, the code for that thing is already given in the bottom of your Jupyter notebook. So you can copy this and put it onto your local code editor. So in this case, the first few parts is the importing parts, which we have done before. But first, we have to first define the model. So if you remember from last workshop, in order to load a model that you've already trained, you need to first define it. Then after that, then you create the model object. Then you update that model with the train weights. So in this case, is load state dict. In my case, this is my file path. In order to get your file path on, I'm not sure on what OS most of you are using, but on MacBook is, if you hold down Option and then right click, you can copy as path. So in this case, it looks like this. For Windows, you can probably just right click and copy and path. There should be an option also. And you have to remember, if you only have a CPU, if you have a CPU only machine, you have to add this line. But if you are on a PC with a GPU or you have a gaming laptop with a GPU, I don't think there's a need to write this. So after that, then we put the model into evaluation mode. So this is from deep learning 1. When you load the model, normally it might be in training mode. So in other words, there is... Okay, but this is not so important now, but later on you realize why we have to do this. So for the... If we go back to the... what we want the app to look like, right? At the top, there's these two tags. So with Streamlit, it's actually very simple to add text. All you need to do is Streamlit the title for that big title, then st.markdown for the smaller text. You can also do st.write lines, .write, sorry. So for example, if I check and run this now, right, to show you all. So it look like this. Yeah. So you can either use streamlit.write, sorry, st.write, st.title, st.markdown. It will show up as different sizes.
Do we have to put the file in the folder and run the Streamlit run file at the correct directory?
Yes. That's why you have to cd into it. But this pt file doesn't matter. As long as you have the full file path here, it should load.
Okay.
Okay, but I hope this shows you how simple Streamlit is to create just a simple website. All you need to do is type like that. But for those that are wondering how to align it to the center, that's a problem with Streamlit. If I'm not wrong, it's still not possible yet, but you can Google it. But to my knowledge, it's still not possible to align the text, for example, to the side. Yeah, then right after this, we will define this canvas. So because Streamlit is written in React, which is written in JavaScript, and Streamlit is as well open source as well, it allows like other people from the community that's not part of Streamlit to write their own modules. Same as how there are so many NPM modules online available for JavaScript. So in this case, this Streamlit drawable canvas is a library that's written by someone else that we'll be using in this tutorial. So this is what it looks like for this, but you don't have to worry too much about this. You can copy it, but these are just the options for it. And here in this case, size we put as 1, 2. This size is the size of this canvas. So if you draw it, this is actually 129 by 129. So this part will look a bit strange if canvas result.image data is not none. Actually, on your notebook, it should look like this. So what this does is that for Python, right, when it sees the if statement, it will first run the condition. So for Streamlit, it will first run this. So this will actually generate this canvas thing. But as long as you have not drawn anything yet, it will continue on to the next one. So once I have drawn something, then the code inside will run. So what happens inside this block is that first, I resize the image back into 28 by 28 because this is what the model intakes. Then I rescale it with this to display it here. Sorry, here. So look like this. The reason why I have to do it like this is because if I put it to 28 here, it will look like this. Oops. Yeah, it will probably look like this small thing. Okay, wait. Oh, and to update the app, all you need to do is save here with Control or Command S, then just refresh. Then it should work again. Okay, that's why we need to name the canvas size of 192 instead of 28 by 28. So actually, if I increase this to, for example, 1000, the canvas will look like this. Very, very big. So that's why we are using 192 and not 28 or any other number. Sorry. Okay, then next part. So after we have drawn a number, for example, in this case, I'm gonna draw 8. We can press the predict. So what this happen, it will run the model and make its prediction. So how it's done in the code is that if the ST button is pressed, this will become true. So if it's not pressed yet, it will completely skip the inside part of this code. So what if you have pressed the button, you first convert the image you have drawn in the canvas into a gray image. Actually, in the Jupyter notebook, it should have comments that tell you what happened. So the canvas actually draws a color image. So first you have to change this into a black and white image. Then after that, actually here I printed it so that it's easier to understand, which you can see here. Oops. Yeah, but this is what the image will look like. But this is an 8 basically. You can kind of make out the shape. But this is what the 28 by 28 array looks like. So after that, we have to change the NumPy array, this NumPy array, into a torch tensor. So this is a problem with, not really a problem, it's a mafan part about PyTorch. You only intake tensors. So you have to first change it into a tensor. And also, okay, this part is because the model, if you remember, when we train it with only values of 0 to 1. So if we suddenly give it an input that is 1 to 255, it will come out with some very weird answer because it doesn't expect something like this. And then here we have an unsqueeze is because if you remember, the model that we use is actually from here. This model. And during the PyTorch, the torch info, the input size is actually 112828. If you instead we only input a 12828 tensor, yeah, it shouldn't run because there's a size mismatch. So that's why we have to unsqueeze it first in order to form a tensor of 112828 here.
So what is the meaning of this unsqueezing, right? Like you might see it this and then see, okay, an image 28 by 28, that makes sense because you have like height and width. Then the second one on the right is one channel. It is a grayscale, one channel. So 128, 28. Then what is the very first one? It denotes the batch of the input. So if you have followed and tried the quiz from the previous workshop, we keep hinting at the idea that you can put in a lot of images through the network at once, and it will take, like, when it calculates the gradient and stepping, it will get the average. So yes, so this the very first number will dictate what is the number of multiple images that will be pushed through at once. So here, when we are doing inference, so after we train, we are doing inference, and we only need one image. So we have to add an additional axis of add an additional dimension of 1. So the term unsqueeze just mean that it will add a dimension, and that dimension will have the value of 1. So unsqueeze 0 is adding that dimension of value 1 at the index 0, which is at the very start. Yeah, so unsqueeze. And otherwise, if you go into the documentation and you read about squeeze just mean, okay, I need to clear out the dimension with value 1. So if you can see in this net, right, net input size is 112828. If we do a squeeze on this torch on this torch tensor, then it will unsqueeze and get us 28 by 28. Yeah, so this is the two operation that have the same help us accomplish the same like meaning, right? We sometimes we want to add an additional dimension of value 1. Sometimes we want to remove it because it is quite redundant. Yeah, so that is the idea.
Okay, yeah, what you said. So now we're moving on after the unsqueeze, which is back to Streamlit again. So as you've seen probably earlier, Streamlit.write just basically writes out the Python string. So in this case, with the string we're writing out is result equals to the maximum number basically inside the 10 size array that I talked about earlier. So if you see this model will output an array of size 1 by 10. So in other words, it's just a 10 element array. So what this array represents is just the probability of each of that index being the number.
Can you actually Streamlit write the array?
Okay, then now I actually,
Just keep it. And yeah.
yeah, I'll print the array now. Sorry. So let's try just putting one into the model. Yeah, so it looks like this. Okay, so in this case, actually the loss function that we use, the loss function that we use is log softmax. So what you see here is the logarithm of the probabilities. So if you have to return it to its actual probability with this. So now I refresh the code, it should give me the actual probability. Yeah. So in this case, it looks like this. It's a bit hard to read the number. So below here is a plot. So for 1, the probability is almost 0.8, actually it's 0.7. Then probability for 2 is this amount, which is very small compared to the other probabilities. Yeah, and there's some probability for 6, 7, and 8. 7 is quite reasonable because 1 actually looks like 7. Then 8 and 6, I'm not sure why, but somehow the model thinks this is 6 and 9. What happens if you draw like some random shape that the model has never seen before? Something like this. So in this case, it thinks it's a 2. Maybe because of this shape here, makes it thinks it's a 2. So if you actually implemented this, it actually gives you a lot of insight as to how the model tries to predict. And you can actually play with it a bit to see what the model thinks several numbers are. For some reason, I think it's a 0, maybe because it spots this circular shape. But I can play with it. Yeah, so that's what this part does. See, for this Streamlit, I just want to say again that this will be very important for those that want to become software engineers or interested in hackathons, because it just gives a very good GUI for your projects or hackathons. Especially hackathons, because like the Python code is directly inside the front end. Instead of like having the model here, instead of having the model processing the input here, you can do any kind of other stuff you want. For example, you can even do the NTU timetable into a actual timetable thing. You can actually code it out into this, then have it out. So you want to build your resume, create projects, join hackathons, it's a very simple tool to use, very useful tool also. And so actually by right, we have come to the end of this workshop. This workshop is very short because it's week 12. You got finals, I also have finals. So I understand if you are rushed for time. But yeah, you can try, it's not really homework. I want to call it homework. You can try implementing far, which is what we did last week, I believe, with Streamlit. So for that, you can try this instead. So ST file uploader. So for MNIST, right, we've been drawing images instead of uploading images. So you can try ST file uploader to see what it does. Actually, I have something else. This is another Streamlit thing that I've created that actually I can show you what it looks like. So this one is a bit more advanced. If you are doing so in the future, there'll be 2 tracks. I think some of you know there'll be a computer vision track and a NLP track. So for the computer vision track, you might be doing something like this. Okay, this is taking extremely long because this actually attempts to load a YOLO model, which is very big. So yeah, you will look something like this. So what this thing does is basically do object detection for tools. At least what it hopes to do. This will take very long, so I'll talk about other stuff in the meantime. So in the future, SEM 2, we will have an NLP track and a CV track. So computer vision will be stuff like object detection, object classification. So after you take a photo, then what kind of object it is, or where is the object, those kind of tasks. Then there will be also a NLP track where you'll be creating large language models. So if possible, actually now it's very busy, you should think about which track you want to be. You can also attend workshops from both tracks also. So if you're more interested in CV stuff, so you can just join both workshops. But this takes extremely long to run. Also Streamlit, the cool thing about Streamlit, it has this running thing that shows when your model is running. So if this was JavaScript, creating something like this would be a very, very big hassle. Because you have to use something called async await for the front end guys. Yeah, but this will take extremely long because this model is humongous. This YOLO model.
So do you want to share about how actually, let's say, Streamlit work a bit at the back end? How is it that we write sequential code and it show up as like a functional app?
Okay, so it will be a bit more front end stuff as my boss wants. So those that have done front end or have tried like basic HTML and CSS will probably know that like HTML is the basic part of the website code and looks something like this. So this one is a bad example of what. Yeah, this is what Google Slides code is. So in this case, actually a lot of JavaScript code. So you see try. But the thing about JavaScript code is that it's created for, unfortunately, front-end developers. So you get a lot of funny behavior. So this is just for fun. Small get away from Python, we'll be trying a bit of JavaScript. So this, for example, there's a lot of simple behavior. For example, something like this. So console.log is actually print in JavaScript. So console.log empty array equals 0 will obviously give you true.
Okay, actually, that was not what I intend.
JavaScript tutorial. No, I just show the JavaScript, how a JavaScript is like.
I see. But it's okay. Right. So what I actually want to allude to is the idea that
That one.
can you show the Streamlit?
Yeah.
The Streamlit code?
Oh, sorry. Streamlit code.
Yeah. So you can see the question that I asked him just now is that we don't have any, let's say, for, while, if, else loop. Oh, okay.
Oh, actually,
There's some if else. but the idea is there's no, let's say, while loop, right? So how is it that the app is still up there and running? So
Yes.
because that is what we learned in Python, right? After the script has run through all the line, then it finished. So technically the program should stop and shut down, but the app is still up there. So I think the point that I want to share was that Streamlit will handle all the JavaScript and the front end thing for you. The idea, can you get me the simple,
This one.
the MNIST
Yeah, this one.
MNIST application in
Oh,
the browser?
so I need to run again.
Oh.
I was running something else.
Oh,
Sorry. But yeah, sorry, wait, let me change this.
so yeah. So the idea is that the a website is kind of static, right? After it has rendered all the elements, it is done. The images, the letters, the characters are still there. You're not interacting with it. It can still stay up there. So the idea is that Streamlit at the back end will continuously listen to your mouse or keyboard input action. So let's say, so what it does is just run through all the code that we just write. So now it is just in a holding position, right? It is not rendering anything. It is only when we write something and the moment I release the mouse, Streamlit will detect that and rerun the whole thing again. Yeah, yeah, you can see the
Yeah.
loop. It is printing out the loop.
Yes.
Yes. So that is why just now, the second example that he shared, he has to upload that YOLO model every time there is some interaction between the mouse and the website. So that is why the website is very slow.
Yes. My boss talks about the correct things. So going off into another off topic again, JavaScript has this thing called an event loop, which will be important if you want to become, if you are going to become a front-end developer. This actually, yeah, it's a bit complex to explain it in a machine learning workshop, but there's this thing that exists that controls the elements. And that's why React is called React. It only reacts when you do something. That's why it's called React. So what I think, we can go back to JavaScript. Go back to JavaScript.
No, let's not go there.
You want to talk about the CV and NLP?
Later. It will be a separate announcement.
That was more or less done.
Okay. Do you want to run through the GPU a bit again? Like how?
Run through the GPU again.
Yeah, in
How
the collab.
Yeah.
What does the various?
Okay. Can. So going back to the collab. Oh, the various images. Okay, this one.
Yeah. What does it mean? Right.
Okay, wait. Let me zoom out a bit. Yeah, so this animation is actually for CPUs. So let me go back to the slides again. For CPUs, each operation is done one by one. So that's what this animation is supposed to show for CPUs. Each core does one operation. If I could create a GPU one, it would be, for example, do one whole row at once, instead of doing this one by one movement. So instead of this red, only one red thing being highlighted, it will be the whole row being highlighted, doing it at once. Yeah. Then as for the coding, it's just very simple. For PyTorch, it's just this. Sorry, where is it? Yeah, this, when you put the device to CUDA and we run this, PyTorch uses this .to method in order to move that tensor into the GPU or into VRAM to be more precise. So, but the problem is most of the time with PyTorch, for tensors that are on the GPU, you can only do operations on those with other tensors there on the GPU. So you very often get an error like something like this. For example, if I don't put here to the GPU, I put it to the CPU instead. Then I run this, then I run the GPU one again. It'll give me an error here because PyTorch wants all your tensors to be on the same device. So you'll show up as error because one tensor is on the CUDA, on the VRAM, then the other one is on the CPU. So going back to the slide images actually, you see that the GPU, the objects must come from the memory. Then likewise for CPU. But the difference is that the memory for the CPU is called RAM. For the computer enthusiasts, you might be familiar with the term RAM. Then if you have a MacBook, it's like 16 gigabytes of RAM, maybe at most. But that's the CPU. RAM is for the CPU. The GPU has own memory called VRAM. So that's why that's why PyTorch doesn't want you to do operations with a tensor on GPU VRAM and another tensor on the CPU's RAM, because it's not possible to directly transfer the object from GPU's VRAM onto the CPU. It has to go through a separate path on the motherboard first. Yeah, so that's why you need to be a bit careful. If you see this kind of errors, it's just because of that. It's not consistent where the tensors are. And actually, that's why if you print certain stuff, you need to run a dot detach. If you remember from the Streamlit, this thing. So in order to display, or in other words, show the result of your model, you have to do dot detach first. Because if let me show you first what if I don't do this. If I don't do dot detach and I run it, even though it wouldn't matter because I'm not using GPU here, yeah, it wouldn't matter this dot detach. But in order to interact with the results of your model, where the model is on the GPU, you need to dot detach, or in other words, remove that object from VRAM and put it back onto CPU in order to display it, in order to show it, and in order to use it. So that's why that exists. Then regarding any other part of the, so what?
Yep, I think that is about it. Even though we only take 1 hour today, I hope it is very fruitful for you. And yeah, that is all. And I hope you can help us fill in. Okay.
Yeah, go see how that guy is doing. Yeah, mute the thing.
Yes. So I hope that will be all. If you have any question, do raise them up. At the moment, we don't have anything else. I hope you can follow the quiz and the feedback to give us the quick feedback for what we did today. Even though it is a 1 hour session only, I hope that it has been fruitful. You have learned more about the various aspects of machine learning, like using GPUs. The floating points are very important because different precision will affect the model differently, and a little bit of the GUI components, the GUI libraries for your own machine learning projects. And yes, so now we are just waiting for you to take any questions. And if you don't have any questions, then that will be it. Thank you very much for coming. And I hope you have a good week 12 and week 13 ahead. Thank you.